Excellent, thank you. Good morning, everybody. So I'm going to talk about going towards a containerized future, but as I am wont to do, we're going to start in the past, sorry. And with containers, let's turn the Wayback Dial all the way back. And I think actually the very earliest history of containers is a little bit murky. So we know that chroot emerges in 7th edition Unix, and we know that Bill Joy is credited with this. But if you know Bill Joy, you know that Bill Joy being credited with something doesn't necessarily mean that he did it. So I think we may need to go to our Unix historians to determine that I believe that Bill Joy did indeed introduce chroot. Supposedly, he introduced chroot to allow him to build BSD 4.2, I guess, on an older system. And chroot, of course, allows you to virtualize the file system. It creates a file system container. And in classic Unix way in 7th edition, so this is in in early 80s, 83. In classic kind of early Unix way, it was a very I'm not sure to say if it was actually elegant or if it was sleazy. The line between elegant and sleazy is so blurred. Really, the difference between elegant and sleazy is only the quality of execution. If you stick the landing, it's elegant, but if you miss the runway, it's sleazy. And chroot is I think it's elegant, but it's a little bit sleazy. And it's sleazy because, as originally conceived, it wasn't really secure at all, and it was very easy to kind of bounce out of a chrooted environment. That was rectified shortly thereafter, and chroot became actually a security mechanism. Probably even today, the most common user of chroot are things like postfix that want to actually execute code that they want to minimize the surface area for. So chroot was actually designed, perhaps designed to allow someone to compile a kernel on an older kernel. It quickly became a security mechanism. That's what chroot was for. That's what containers were for. And FreeBSD extended this with jails. And I just love, even with the term jails, it's a pejorative, right? So my application is a convict? God, what happens? And I don't even think I want to know what happens to that application in jail. And I guess they couldn't quite call it prisons, I guess. But jails, I think, very much reflects the FreeBSD thinking of containers, namely containers as a way to minimize the system surface area to run code that is dubious, borderline untrusted. So containers were actually born, ironically enough, as a security mechanism, but quickly they expanded beyond this. At Sun, we saw the potential for jails to be much more than simply a containment mechanism. And actually we saw, bluntly, as a way to sell really big gear. Because when you are trying to sell a gigantic physical machine, something that doesn't actually exist anymore, but just bear with me for a moment, if you're trying to sell a gigantic physical machine, you need to have many, many, many workloads on that machine. And containers we viewed as the path to do that. I say we because I was at Sun for 14 years. And we viewed containers as the way to do that, and we developed zones. Zones were jails taken to their logical conclusion, where you had a true virtual operating system that you could deploy an application into. You could run disjoint applications. And what we found is that actually people loved zones because they could get out of dependency hell. Some things never change. They could actually get out of dependency hell by having mutually exclusive dependencies in different containers. So this became a big deal, and it became a different way of thinking about this mechanism that was born as a security mechanism, and it had really clear advantages with respect to performance and efficiency. This is extremely efficient. Containers are lightweight. This is great. It's a great idea. Okay, done. We virtualized. We can move on. Well, not quite so fast. Because the problem with containers, such as it was, is it actually required a great deal of OS modification. The operating system kernel had to be modified a great deal, and you didn't get to choose your OS kernel. Your OS kernel had to be, back with zones back in the day, had to be Solaris. And the demands for virtualization in the early 2000s were actually different. It wasn't just about workload consolidation. It was actually about taking physical machines, many, many, many physical machines, and consolidating them. And those physical machines actually weren't running Solaris, and they weren't running Linux either. They were running Windows. And VMware actually, the VMware of course, the company that did this, and by the way, before VMware virtualized the x86, many reasonable people thought it was impossible. It was thought to be impossible to actually virtualize x86. VMware did it in a very, very clever way. And what they actually made their business on was taking many Windows machines and running them with hardware virtualization. So what is hardware level virtualization? Because hardware level virtualization is actually the oldest way we have of virtualizing the system. And so to give you a little bit of background on what that is, it actually dates back, like many things, to the 1960s. And actually the history here is very interesting because it actually dates back to the very earliest machines. And in the 1960s, IBM had, because everything was IBM essentially, IBM had a bunch of disjoint computing lines. And they wanted to unify this with the instruction set to rule them all. And this was going to be System 360. And System 360, so-called because 360 degrees of view, System 360 was going to unify the 1401 and the IBM 650 and the 7090 and so on. But it was going to do it with this new, beautiful instruction set that couldn't actually execute any of those dirty old binaries. So 360 comes out, and again, this is in the mid-60s. And as it turns out, this is amazing to me, that even by the mid-60s, software had more weight than hardware. And the idea of actually rewriting my software for a new shiny piece of hardware, not so exciting actually. And so 360 wasn't really selling. And into this gap came Honeywell. And Honeywell had a machine, the H200, and what they saw was that the IBM 1401 was the most popular machine of its day. And what they realized, they had the great insight, why don't we make an H200 look like a 1401? We'll write software to make the H200 look like a 1401. And they did this, and they were able to execute these binaries. And the name of the software is just great. You just can't recreate this stuff. It was called the Liberator. This is when I miss the Cold War so much. The Liberator, if it was going to be the name of execution software, it would have been the name of an ICBM or a bomber. Anyway, so the Liberator was going to liberate you from IBM, and it was going to allow you to run the 1401 on the H200. Worked like a champ. IBM sees this, and they immediately implement a 1401 layer for the 360, and that 1401 layer stayed with the product for many, many years. And in fact, an interesting kind of epitaph on this, I was sitting with one of the most amazing moments of my career. I was sitting with the CIO of a very large bank right after Y2k. And for you children in the room, it was a kind of a non-event. Don't just check out Wikipedia. But we were talking about what our biggest Y2k problems were. And he said, it's funny because 45% of my Y2k problems came from a single hardware platform. Go on. The IBM 1401. I swear there were bits of my brain on the ceiling. That the IBM 1401, that was, for my father, is an old machine. This is a machine that was last made in the early 60s. This is a very old machine, is here running in production in 2000. That is stunning. And actually, it should give you, I know it feels like we always rewrite software all the time, and software is transient. Software actually has an amazing permanence, and that's reflected there. And hardware virtualization allows you to achieve that. Hardware virtualization allows you to take the past with you into the future, and it's awesome at that. Because the abstraction that you're making available is the hardware. And this guest operating system has no idea that it's actually running on a lie, which is, virtualization is a euphemism for lying, if you haven't figured that out. And people that are into virtualization are actually basically pathological liars. And those of us that do virtualization at kind of the lowest layer of the stack are pathological liars and control freaks. We're really very broken people in many ways. But with hardware virtualization, we have this very effective lie. It works really, really, really well. In terms of running those legacy stacks. It does not work very well from a performance perspective. Because once you actually get this thing running, okay, great. But now all these lies, I begin to see these lies when I go to do I/O, and my I/O is slow. It's like, I did I/O, like, why is the I/O not performing? It's like, because you've got no idea what has to happen to get your I/O to an actual, the lies that have to be unfolded, the cover-ups that are exposed, the criminal trials that have to happen to get that I/O to you and your guests. It boggles the mind, right? It's a sausage factory. But so that you begin to see the lie when you see performance, when you see tenancy. These are guest operating systems. They don't actually share resources very well. So you may be able to have tens, maybe hundreds, but thousands on a machine is going to really, really hurt. But nonetheless, despite these perhaps disadvantages, hardware virtualization, because it is so effective at running these legacy loads, it became the de facto standard. And great for running Windows, that's fine. You're like, okay, hardware virtualization, fine, 1401, blah, 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 fine, ancient history, Windows, who cares? We're not using that today. Well, actually, we are using that today. And if you go to Amazon today and you spin up an instance at Amazon, you are spinning up a virtual x86. And when you are booting your guest operating system, you are replaying the history of the personal computer starting in Boca Raton 1979. It's tragic what happens. And then you're like, God, why isn't this thing not spinning up faster? It's like, because we're replaying all of history. That's why. So it cuts against us a great deal when we're looking in the cloud. We had the kind of containers were on one path, and hardware virtualization was effectively on another. At Joyent, where I'm the CTO, we've been running OS containers in production for a long time, since 2006. We've believed very strongly in OS-based virtualization. Containers were the organizing principle, effectively, of Joyent. And we've got our own operating system, SmartOS, which is actually a derivative of it's a long story, but the Solaris became open and then it became closed again, and thank you, Oracle. We actually, SmartOS inherits that heritage from the open Solaris zone. So we've been running this in production for a long, long time. And these containers, again, they're lightweight, they're efficient, and what we're especially seeing in this modern world of microservices is that efficiency is suddenly very, very important, because the overhead, when you've got a million of these little microservices, the overhead of having a hardware virtual machine becomes really debilitating. The latency becomes very important. So we've been very, very, very strong believers, but we've always emphasized their operational characteristics of containers. This is to say, containers are more efficient, they perform better, they've got better density. And for many years, we were a very lonely voice. And then, while we were so we were talking about containers, we've got hardware virtualization in the cloud. Meanwhile, other people are viewing that actually containers might be an interesting foundation for a PaaS. Containers are actually a really good way to build a platform as a service. Of course, platform as a service is actually a terrible business, as it turns out. And there was one platform as a service company that, as they say, you haven't heard of for a reason, called .cloud, that had a platform as a service that was basically struggling. But people were really interested in the software they were using to actually provision their platform as a service, because they were using containers heavily. And they actually open sourced this in 2013, and Docker was born at 2 minutes into this presentation from Solomon. So they open source Docker. All of a sudden, Docker explodes with interest. And the reason that Docker exploded with interest is because Docker connects to the developer. What Docker has done is it used a different aspect of containers, and actually it's the aspect that Bill Joy was putatively using back in the day. Namely, they're using the ability to easily create a static kind of development environment, and to actually allow developers to think operationally, to actually build something on their laptop that looks exactly what's going to run in production, and then ship that into production. That's the kind of the dream, the vision of Docker. You're able to encode this development kind of junk in an image, so it doesn't have to be seen. So people don't have to know that you're using Clojure, for example, which your ops people would have a seizure over. You can just hide that in your container, in this statically linked goober that you can then just run into production. And you can reliably do this. You get this. Once you've generated this, you've got the exact same thing. I can run the exact same thing. If this one doesn't work, I can roll back to what I used to be running. So this is the reason that Docker is catching on, I think it's fair to say, is because it is solving a real problem that developers actually have. And I said before, I will say it many times again, that Docker will do to apt what apt did to tar. So apt is of course, the packaging format in Ubuntu, packaging software in Ubuntu, in Debian, and apt is built on top of the way we archive files, CPIO and tar. But you don't actually think in those things anymore. You think in terms of this higher packaging format. Docker is going to allow us to think in a higher format yet again. Containers are going to allow us to think in that higher format yet again. So, but there's a broader container revolution afoot. It kind of has started with Docker, but there's a much broader revolution transformation afoot. And I think that the Docker model kind of shows us what the future is, but there are challenges with Docker today. And those challenges are actually operational challenges. They are network virtualization, persistence, security, and so on. And ironically, these are the things that we've actually solved, right? And what's just slays me is that right now, the state of the art for deploying Docker in production. How many of you deploy Docker into production, by the way? Okay. How many of you are doing so in VMs? It's fine. It's fine. It's okay. I'm not going to judge. It's a judgment-free zone. Glad that you had. So you're deploying them in VMs. That's not a value judgment. That's because that's kind of the state of the art right now, is to deploy a Docker host sitting in a VM and then many containers sitting in that VM. And I know it's not wrong, but it is wrong. And it's wrong like capital W wrong. It's like God is angry wrong. That we have this terrific technology for delivering efficiency, and we're undermining that by strapping it onto the IBM 1401. And that's wrong. So it's especially wrong because what we're doing with these Docker hosts, these Docker hosts are recreating the physical infrastructure problem that we actually solved with virtualization. And now, instead of physical infrastructure, you have virtual infrastructure on which you're going to put many little containers. The whole like pets versus cattle. Okay, I'm all for pets versus cattle. And the containers are not pets, they're cattle. Great. They are sitting on top of pets that are these Docker hosts. Your Docker hosts are pets. And that's a problem. We need to get rid of that. And that layer, that managerial layer, just cuts against us. It's complicated. It's not needed. We want to eliminate that. And indeed, I would say that when you deploy an OS container via a Docker host and a hardware virtual machine, you negate the fundamental economic advantage. So can we get to container native infrastructure? I mean, this is the kind of problem we pose in front of us. Because over here, we've had SmartOS. We've been container native since our inception. We've been internet-facing forever. So we've got a great deal of confidence in its security, its multi-tenant, and so on. It performs very well. Could we somehow mate this with this world of Docker where we had this great developer enthusiasm, where we've got this great developer capture? Can we get the best of both worlds? Can we get the agility of Docker with the production-proven security and on-the-metal performance of SmartOS? Now, that said, there are some obvious obstacles. Obstacle number one is, well, there's this whole Linux thing. Namely, the Docker ecosystem is rightly all Linux-based, Linux-centric. Kind of Microsoft entering the whole Microsoft thing aside, it's essentially all Linux binaries, right? And SmartOS is Unix, but it's not Linux. It's like close, but it kind of near miss. So the first problem we had to solve is we had to actually be able to execute Linux binaries natively on SmartOS. For this, we were able to actually resurrect a technology called LX branded zones that allow us to actually have a Linux system call table on top of a SmartOS kernel and to swap that in when we're actually executing a Linux process. And because actually Linux is actually Unix, and they're actually close enough on things like the data path, we're able to do this very efficiently and without actually a performance overhead for things that are in the data path. So the technical details are way beyond the scope of this presentation, but suffice it to say it works. This is someone running XFCE plus Firefox plus Skype desktop on Ubuntu 14.04 running on SmartOS, and running dtrace there in the terminal. To which someone replied, because we think this is kind of a big deal. Someone else like, okay, I guess that's a good thing, right? I think that's a good thing. Sometimes people make up swear words, you don't know what they mean. This is a tweet from last night that I kind of like. This is just a user in the community. 9 out of 10 Linux users don't realize it's actually Illumos. Of course, the Illumos word is SmartOS is a derivative of Lumos. Of course, I want to know who's the 1 out of 10 who actually thinks who actually gets it. Someone replied, the last one is probably using Haskell. I don't even know if that's an insult or not. I mean, the last one running Haskell, I think probably thinks, do they know what planet they're on? I mean, are they, Haskell is so strange because it's a community that prides itself on such beauty of code and yet has such absolute filth in its actual development environment. And have you ever used Cabal? If you go to Cabal is the packaging manager for Haskell. If you Google Cabal, Google will suggest hell to you. I mean, it actually really is that bad. And actually, Haskell is a big user of Docker because there's no other way to build a Haskell development environment. So anyway, I'm done throwing Haskell under the bus. So that was kind of, we got the binary problem solved. We're able to execute Linux binaries fine. Now the next question is, can we actually go provision Docker containers? So can we actually take a Docker container and actually provision it on one of these things that's running on the metal? Well, this is a serious problem, or a challenging problem, because in our model, that thing's going to run on the metal. We're not going to take the Docker engine and download it off the internet and run it on the control plane of the cloud. That's just not going to happen. Because if you break into the control plane of the public cloud, because we operate a public cloud, you break into the control plane of the public cloud, you can delete the company. This is true of Amazon and anybody else. If you're in the control plane, you can do basically an unbounded amount of damage. So as we found out when we had an administrator accidentally reboot an entire data center, that's a different story. But so it was very important to us. We got to keep that software effectively out of the control plane. So we need another way of doing this. And the Docker itself had a ton of embedded Go-isms and Linux-isms. It just didn't make sense to take the Docker itself and try to run that in the global zone, try to use Docker itself to provision. But fortunately, there's actually an interface. And I'm hoping you guys know this guy. You guys know this guy? He's on your currency. So do you know who this is? Anyone tell me? Okay, this is George Stephenson. So he's on your £5 note. Maybe everyone just uses their credit card or whatever. You should know if you're born in the UK, you live in the UK, you should know this guy. He's a stud, okay? So George Stephenson, Victorian railway engineer, and George Stephenson invented the first and most important interface, namely railroad gauge. So George Stephenson had the very strong belief that the gauges had to be uniform. I think he picked number 2 here. It's hilarious to read the fights over the different gauges and their technical attributes from the Victorian era. I swear this is like Victorian Hacker News. Where people, because they will make up all these engineering reasons why like 3 is terrible, and of course you want to be on 4. It's like, oh my God, I can't believe you're on 4. No, you need to be on 2. Anyway. So the interface is actually very important. Actually, kind of a funny story here. The first major railway, I'm sorry, I can't resist telling this. The first major railway that was built was from Manchester to Liverpool in 1830. And George Stephenson leads the charge on this, builds this railway. So they have like their big demo day, right? We're going to launch the railway. They have the railway. They got the Duke of Wellington out. Okay, we're going to get going. The railway gets going from Liverpool to Manchester, and they've got all these cars on it, and the train derails. Okay, well, no one's hurt, so get the train back on the tracks. While they get the train back on the tracks, another train rear ends it. Okay, so things still seem like kind of, okay, like let's get everything back on the rails. And they kind of make forward progress again. They stop at one point, and then a member of parliament gets out and gets hit and killed by another train. It's like, wow, worst demo ever. So then they're like, okay, let's go back. This is awful. But as it turns out, by that point, the crowds in Manchester were violently angry that the train hadn't arrived, and they felt they had to go on to Manchester. It says a lot about Manchester, by the way. So they finally get down to Manchester, and they get pelted with things. They have to turn back. And like, oh my God, this is like total disaster, right? And like this dude is dead. A member of parliament is dead. Like he's important. He's dead. Everything's a mess. And then this guy has a funeral. And people, I mean, it's amazing. People are like, wait a minute, there's a train from Liverpool to Manchester? That's awesome. So the funeral, like this funeral, if the dude hadn't died, the world would not have known about how great this was. So it's like, if you ever think you're on the bleeding edge, at least no one is dead, right? But never invite the Duke of Wellington, by the way, to a demo. I think that's what I learned from that. Anyway, so you got George Stephenson. I don't know if you know this guy. You are true. Like, you're going into the container metaphor way too far if you know this guy on the right, but he actually played a very important role in modern commerce. This is Keith Tantlinger. Keith Tantlinger invented something called the twist lock, and the twist lock is what allows containers to actually stack on one another. So the twist lock goes on each corner of a container. This is what allows a container to mate onto another, be locked, an actual container, not like a HTTPS Docker container, an actual real container, people doing real things, right? As opposed to like, your mom still doesn't understand what you do for a living. And if you only actually worked on shipping containers, you could actually explain it to her. I think Keith Tandlinger had a much easier time with his mother. Anyway, but both of these things show the power of an interface. Both of these things literally revolutionized commerce because of the value of the interface and the very strong belief that these two engineers had in making those interfaces available and standardized and public and so on. And Docker actually has a terrific interface. Docker, as it turns out, has a remote API. And that remote API, which we were very, very actually happy to discover, the remote API is actually a very good API. That API actually allows us to actually not have to have a Docker host sitting on a physical machine. It actually allows us to virtualize Docker. And that's actually what we've done with Triton. So Triton is a software that we've been developing for the last year or so. We announced it in March, all open source. We've been in GA in production in the Joint Public Cloud since the summer. And so what Triton does is it takes Smart Data Center, which is our orchestration software for SmartOS, and it puts on top of that a Docker remote API such that your Docker host is the entire data center. If you do a Docker PS, you see your containers across the entire data center. When you go to actually do a Docker run, you give it a container. That's going to just as when you provision a VM in the cloud, that's going to find a compute node on which to run. It's going to provision that thing, and then it's going to run. And you don't have any VMs at all. The VMs are gone. They're out of the picture. What you pay for are the containers. You only pay for the containers you use. And importantly, although I think it's actually, for many people, it may be the least important thing at the moment, but from my perspective, importantly, it performs really well. It performs great because you are actually sitting on the metal. You're not sitting captive in a VM. That said, I actually think that the much bigger win for Triton is the fact that it eliminates this managerial complexity of the VM layer that you don't actually need. So in terms of the container landscape, in terms of where things are going, certainly I think that we would all agree. I mean, witness the fact that we're here. We got Container Camp and Container Summits and everything else. Containers are clearly the future of application deployment development. So I mean, this is a thing, right? It's real. No doubt about that. The upstack ramifications are entirely unclear, which is a total euphemism for, I mean, it's just a food fight in terms of these upstack things, right? There's a lot going on. I used to say it was the Wild Wild West, but the Wild Wild West was never this wild. Now I think it's like middle school, but now it's like middle school with guns. Middle school with like guns and blog entries. So there's there are a lot of rival frameworks. There are things that are mutually exclusive. There are things that are merging all the time. But it's an all open source world. How great is that? This is all open. What we have now, actually the challenge we have now is the paradox of choice, that we've got so many choices available, but I think as a result, it's not going to be winner take all. There are going to be a lot of productive, interesting mutations. Triton is all open source. Kubernetes is all open source. CoreOS is all open source. Docker is all open source. All these RancherOS, all this stuff, you go upstairs to the hall up there, all of those things are open source. How great is that? It means that we're going to have a lot of really interesting mutations. It's not going to be winner take all. We've taken a modular approach. I think we're seeing that a lot from other people as well, because what we see is the container is a general purpose foundation, and we don't want to make too many upstack decisions for you. That said, there are a lot of things that are upstack we've got to figure out. In terms of realizing this, realizing the full container revolution, understand the container revolution does not stop with compute. And one of the things, again, we've been at this for so long, one of the ideas that we actually came to quite some time ago was like, wait a minute, containers could actually revolutionize the way we think of object storage. So object storage like S3, we've got our own object store called Manta, and it's just like S3 in terms of you use HTTP, put and get to store and retrieve objects. But unlike S3, you can actually spin up a container where an object lives and compute upon it. So if you want to grep through 1 million log files, you actually use grep to do it. You have a container that actually executes grep. And it's what we've discovered is that the world wasn't quite ready for that idea, because people be like, wait a minute, where's the VM? It's like, no, there is no VM. It's like, oh, okay, but how do I run Hadoop on it? It's like, no, you don't run Hadoop. Okay. All right, you know what? We'll go do the Docker container thing first. But you got Manta. Manta is sitting there. It's in the future, but it's available today. And there are going to be more things like that. Containers are going to spread to beyond just compute. We're going to see it in storage. We're going to see it in networking. We're going to see it in all these elements, and it's going to bring things together, I think, in a really interesting way. So, but in order to do all this, we have got to break the many-to-one relationship between containers and VMs. Note, I actually emphasize the many-to-one relationship as the problem, not necessarily even the VMs, because I don't know if you've seen what VMware has done with their Bonneville stuff. It's actually really interesting. What they've done with Bonneville is they've got a VM has a single container in it, and it's mated onto that container. That's actually really interesting, and VMware sees the same problem that we see, that we've got to get rid of these hosts that are running a bunch of containers. And you've got to have this kind of one-to-one relationship. So while the container's not running directly on the metal, there's still a VM in there. It in spirit is actually, ironically, very, very similar to what we have done. So the Bonneville stuff you definitely want to check out. Really interesting stuff. And actually, Ben is here, and there you go, raise his hand, so you can go talk to Ben. Really interesting stuff. We really like what the VMware guys have done. And a lot of shared values in there. So I don't want to throw hardware virtualization too far under the bus. I always apologize to Ben after all of these presentations. And he always forgives me in that very English way, where I'm forgiven, but actually not forgiven. Where he apologizes, but it's clear I should be apologizing. So anyway, oh, I'm sorry you said that. I'm oh, wait a minute. Oh, you're not actually sorry. Anyway, but we love what VMware's doing, and because it's got that same model of eliminating the kind of the mental tax that is sitting right now in the Docker host layer. So in terms of the future, again, for a decade, we have believed fervently in our marrow that OS-based virtualization is the future of computing. I didn't really know how it was going to unfold, but knew the rest of the world was going to have to figure out what we knew. But again, we've got to run these things directly on the metal. We've got to have multi-tenant security as a constraint. I think especially with the Docker host is going to become a vestigial abstraction, and we need to actually eliminate it. And again, Triton represents our belief that containers don't have to compromise. You can have it all: multi-tenant security, operational elasticity, and on-the-metal performance. With that, thank you very much.